Report, a podcast with news and information on high-performance computing. Today, my guest is from Nimbus Data. We have the founder, president, and CEO, Tom Isakovich. Tom, welcome to the show today.
Well, thank you very much. It's a pleasure to be here.
Hey, it's really my pleasure. I brought your slides up. Why don't we go into that, and we'll follow it with a Q&A.
Okay, well, that sounds wonderful. Thank you so much again. So first, just briefly, I'd like to spend a minute on some recent highlights from Nimbus. As you may recall, we announced our S-Class Generation 2 product back in August of 2011. This was our second generation all-flash network storage system. And to this day, it remains the only multi-protocol flash-based storage system on the market. It's unique in that it supports fiber channel, 10 gigabit Ethernet, and QDR InfiniBand, all on a single flash memory-based platform. It's also unique in its architecture. It features a non-blocking internal fabric, which is vastly superior to the typically oversubscribed mid-planes of most disk arrays. And this allows us to achieve exceedingly high IOs and gigabytes per second of throughput, up to 800,000 IOPS and 8 gigabytes per second of throughput. And finally, the S-Class continues Nimbus's leadership in software. We have built over the last 6 years an operating system called Halo that provides for advanced data management services built into the system. Features that include snapshots, encryption, thin provision application, and much more. Now, as a company, we've also had a fantastic past year. We closed 2011 with our third consecutive year of profitability. We also last month moved into a brand new headquarters in South San Francisco, which is very exciting. And we were gracious enough to win a couple of awards. Tech Awards gave us the 2011 Product of the Year, and SearchStorage.com awarded us the Top 10 Startups designation as well. From a customer perspective, certainly the industry has really awoken to flash technology and particularly Nimbus's sustainable storage technology. We announced a major customer win back in August of eBay deploying 100 terabytes of Nimbus flash memory to power their virtualization infrastructure with VMware. But we've also now expanded our customer set to include a wide variety of customers, from semiconductors to energy to governments to supercomputing. So it really now runs a pretty broad array of different customers. Those include, for example, one of the top 3 providers of virtualization software, the top provider of digital news, one of the largest, 3 of the 10 largest semiconductor companies, the number 1 provider of post-production technology, the number 1 provider of freight management technology online, a significant deployment with the U.S. Department of Defense. Also, one of the top 3 supercomputing centers is a Nimbus customer. One of the top 5 providers of electrical power systems is one of our customers, and also a leading provider of software for financial portfolio optimization. The hedge fund industry is one of our customers. So it really runs the gamut from technology companies to the federal government to high-performance computing companies to financial services, all across the board. Also, we are dramatically expanding our distribution reach. We announced about 2 weeks ago the launching of our Flashpoint Partner Program. And this program currently has 15 solution providers in the network right now. We expect this to grow to probably about 50 by the end of the calendar year. We're also going to be announcing federal distribution shortly, as well as broadline distribution. And this is all part of enabling Nimbus technology to be distributed primarily through solution providers. We see solution providers as really offering the missing link to connect advanced technologies such as ours with end users that are looking to deploy it. We've also expanded internationally. We have customers now in Europe, several different countries, from the UK to the Netherlands, France, Germany, as well as Asia, in Japan, Hong Kong, and also China. We've also reached beyond our borders. So the big announcement that we are making on January 31st is the release of our new EClass product. The EClass extends Nimbus's sustainable storage technology to mission-critical enterprise and cloud infrastructure environments. So effectively, this is several steps up the food chain, if you will, from the S-Class product, geared toward the availability and capacity demands at the high end of the market. In this case, the E stands for enterprise and efficiency. And I'll talk more about our enterprise features and our efficiency attributes as we go through this. But in a nutshell, first, the breakthrough features include a no single point of failure architecture, meaning the system has full redundancy for both storage as well as controllers. It's also the most scalable flash-based storage system ever produced, scaling to 500 terabytes of flash memory in a single file system with a single management interface. It's also the most efficient primary storage system ever engineered, with power consumption as low as 5 watts per terabyte, enabling greener data centers than ever before. And finally, we've achieved this while having the smallest footprint of any primary storage system in terms of data center rack space density and the cooling required to support this system. In terms of fault tolerance, the new EClass features no single point of failure. What we found in mission-critical customers and cloud environments and large-scale HPC deployments is a desire for absolute 24/7 operation with full redundancy for both the storage as well as the processing portion of the storage system. And so with the EClass, we, for the first time, introduced fault-tolerant redundant controllers. This design also enables us to have non-disruptive software updates, as well as non-disruptive and automatic controller failover. And also, customers can very flexibly add capacity on demand while the system is in production. So even if they start with a modest configuration of 10 or 20 terabytes, they can expand it without any interruption all the way up to 500 terabytes in a single system. Now, these features are new in addition to high availability capabilities we've had already in the original S-Class. Things like active-active I/O modules, redundant power supplies, redundant fans, hot swappable flash modules, as well as RAID 5, 6, and 10 redundancy with sparing, as well as EMLC enterprise-grade flash silicon with a 28% reserve. So we've taken these existing attributes and we've made them even better now with the EClass by adding the controller redundancy, non-disruptive software updates, and so on. So in terms of scale and efficiency, with the new EClass, we've built the most scalable flash system ever made. It scales up to 500 terabytes in a single file system. Our closest competitor is just 1/20th that level of scalability. So for customers that are looking for very large-scale deployments of flash, Nimbus is the first to have done so and really push all the way up to the half petabyte mark with flash. What's also exciting is we've done this while maintaining unified storage technology, meaning you can present the Nimbus storage both as SAN or as NAS or as a combination of the two protocols simultaneously. Now, with this, we've also built the most efficient system ever by, again, driving power consumption down to levels that are somewhat almost unimaginable, that you could deploy 20 terabytes of flash for the comparable power consumption of a light bulb. And we've really, again, made, as part of this sustainable storage vision that we've outlined, we've made power consumption a key factor. So hitting this very low power, again, we find is critical to controlling data center costs. We've also focused on density. Rack space is a premium. It's very expensive to deploy new rack space in terms of cooling and floor tiles and power and everything else. So by minimizing rack space and minimizing floor tiles, we've also set a new standard. Today with the EClass, we are at 10 terabytes per U, which allows you to deploy 440 terabytes of flash memory in one single rack. That's a huge improvement over what can be done compared to this. And we've also done so while reducing the cooling requirements pretty significantly, about 80% lower cooling than conventional disk-based systems. So what's the reason for all this? Well, first, the major benefit is that this kind of technology enables hyper-consolidation in the data center. If you're looking, for example, just at the performance attributes of the Nimbus in terms of IOs per second, it would take 14 racks of 15,000 RPM spinning disks to deliver the equivalent IO capability of just one rack of Nimbus EClass. So for environments that, again, are very storage performance centric and may have been deploying just more and more spindles over the past several years in an attempt to improve performance, oftentimes not actually needing the capacity, but just buying spindles for the sake of the performance, you can see how Nimbus will enable a much more efficient way of doing things, being able to consolidate all those spindles down to a much tighter package with 14 times the performance coming from the Nimbus. You can advance to slide 9, where you see that our technology also enables dramatically greener data centers. Cooling cost is a big contributor not only to pollution, but also to operating expenses. So by reducing the BTU cooling requirement of the storage, you can build a greener, more sustainable data center. Nimbus here shows that for just 100 terabytes of capacity, we can reduce the BTU cooling requirement from 8,500 BTUs, which would be necessary for disk, down to 1,700 BTUs, which is what would be necessary for the Nimbus EClass. So significant cooling reduction. On slide 10, we show that as well as reducing cooling, we're reducing power. With a conventional disk array, power consumption is in the neighborhood of about 25 watts per terabyte. But with the Nimbus EClass, we've brought that down to just 5 watts per terabyte. So that's an 80% reduction in energy consumption, which again, not only helps build a greener data center, but also a less expensive data center. Less power means less energy costs and less UPS infrastructure to battery back that infrastructure. Or finally, the Nimbus also enables data center rack space reclamation. We reduce the footprint of capacity of storage in the data center. And this is something that is, I think, rather remarkable if you consider the relatively short history of flash memory compared to the very long history of 15,000 RPM disks. If you think about it, for years, 15,000 RPM disks have improved their areal density at a pace that was rather remarkable. But over the past couple of years, the annualized improvement in areal density of 15,000 RPM disk has been actually rather modest, only around 30 to 40%. With flash technology, we've already been able to eclipse the density possibilities of disk. In fact, our flash solution today, the EClass, is 3 times the density of 15,000 RPM disk. And where 15,000 RPM disk seems to be running out of steam in the areal density game, flash is actually just hitting its stride. So we see the density advantages of flash actually improving from not just 3x, but even multiples beyond this over the next 2 or 3 years. What this means for customers, of course, is that if they need to deploy hundreds of terabytes or petabytes, they can do so with less rack space if they go flash compared to doing it with 15K disk. The EClass, as an all-flash system with multi-protocol capabilities, is really applicable to a wide array of different applications. On one hand, there are the enterprise use cases, such as virtualization and cloud and virtual desktop infrastructure. And on the other end are the high-performance computing requirements. We've spoken with many semiconductor companies with HPC-like workloads, many of the energy companies, many supercomputing centers, also in the biotechnology field where they have large-scale sequencing analysis that needs to be done. All of these applications are both processor-intensive but also extremely storage-intensive. And they're storage-intensive not just in performance but also in capacity. So the large-scale capacity that's possible with the EClass, we think, will be a real boon to the HPC community. The product, the EClass, will be available on January 31st when we announce it. It is a generally available product, shipping now. And it will become a new member of the Nimbus Sustainable Storage platform. We will continue, of course, to offer the S-Class product, which is exceedingly popular. It is a wonderful solution that starts at a very cost-effective price point, scales very nicely in its own right, and at 5 terabytes per U and $10 per gig is a very efficient and cost-effective solution. But the E-Class occupies a bit upmarket the demands that higher-end customers have for no single point of failure and even more terabytes, up to 500 terabytes in this case. We've done this while maintaining a similar price point as the S-Class, and we've also done this while keeping the software, the Halo software that we're so well known for, consistent on both the S-Class and the E-Class products. So we have one same software stack, one common management interface. And with that, that concludes my portion of the presentation. And Rich, I'd love to take your questions if you have some.
Sure. Thanks for that, Tom. You know, it seems like this is a inevitable move, right, to the enterprise with these highly available systems. Does this bring you a whole new set of competitors in this space?
Well, I think yes and no. In some respects, we've already been competing with the large incumbent companies for some time. Flash memory storage, because of its performance, is immediately attractive to high-end customers. And those high-end users already have existing incumbent storage relationships. And the incumbents have been largely trying to, I think, delay the adoption of Flash by focusing on tiering solutions or on caching-based solutions. So we've already been competing with many of them to begin with. I do, though, agree that this does put us kind of more in their in their sights, because now with the mission-critical no single point of failure, we can go toe-to-toe for the core production, which is the pride and joy of a lot of these large incumbent storage vendors.
So Tom, in that vein, it seems like there's a lot of Flash startups out there, but you seem to be in the lead as far as taking this position as you're ready to go up against the enterprise class spinning Rust, as we call it. Is that a fair assessment?
Well, definitely. To be candid, on a competitive note, the ones that we're concerned about predominantly are the incumbents, because you have to present to the end user a motivation to leave an established vendor. And sometimes they're very eager to leave, and sometimes they're not so much. So it has to be a pretty compelling argument. The bar is so high in the enterprise. If you think about it, you need to have a comprehensive software stack, and that is a huge challenge in and of itself. And Nimbus has delivered on that with our Halo operating system, which has been in development for over 6 years. We have over 200 deployments of the technology. It's solid, it's robust, and it's feature complete. And then also you have to be proven, right? If you're going to go into the enterprise, you don't walk in there with no track record. And Nimbus having shipped, such, for example, hundreds of terabytes as we did to companies like eBay and the Department of Defense and so on, we have a track record, a very good one. And I think third, too, as a company, you need to show that you have staying power. The fact that Nimbus is profitable and has been profitable for years gives our customers a lot of confidence that we're going to be here for the long run. So while we do see, some noise coming from other Flash companies, and there's definitely a lot of hand-waving in the space, there really hasn't been a lot of meat on the bone there so far. A few, if any, are even shipping product, and we think a good 2 or 3 years, if not more, behind us in terms of software and hardware capabilities.
So, as you move to the enterprise space, how do you get that HA capability? Is it primarily a software kind of approach where you do things like RAID? And because we hear about how Flash starts degrading over time, right? Well,
there's a couple of different areas where you have to address high availability. Certainly on the Flash silicon itself, Flash, unlike disk, has a finite lifespan, and that lifespan must be managed very prudently. With Nimbus, that's why we've selected only to use enterprise-grade memory. The enterprise-grade memory, the EMLC technology, that is, is 10 times more durable than conventional consumer-grade MLC. And so that gives us a starting point that's already well ahead of any MLC solution when it comes to durability. Then we further extend that durability by having ASICs on every flash module that extend it further through ECCs, wear leveling, and other technology. We also have a 28% reserve of additional capacity on every flash module, so that in the event, for whatever reason, if some cells prematurely go bad or go bad in some unexpected way, we have a whole 28% reserve we can draw upon to transparently backfill anything that went wrong. And then above all of this, we still do RAID. And that RAID can be RAID 5 or RAID 6 or RAID 10, again, providing for hot swappable flash modules so that even if you have a module failure, you can replace that module without any interruption to data access or any data loss. And then yet again, above that comes the controller redundancy. You know, that is what makes the EClass so special, because those things that I already mentioned, we've already had that for since the original S-Class. But now we also add the controller redundancy, which gives customers comfort along the lines of, hey, what if the actual processors in the system go bad? Or if the software has a corruption event and panics? How do you provide redundancy against that? Well, that, of course, requires software to be able to be smart enough to detect that kind of situation occurring. And then also hardware that's capable of failing over and failing over fast enough before any applications realize that anything's gone wrong. And I got to tell you, that is not easy to do, particularly the failover. It's one thing to have two controllers, but it's another thing to be able to fail over in a couple of seconds with the applications being none the wiser than anything went wrong. And that we've achieved with the EClass.
And then what about the cost, Tom? Is it coming close to parity with the high end 15,000 RPM kind of spinning disk? Is it approaching that in the HA space?
Well, at the component level, the truth is it has not yet. 15K disk prices have actually been going up, which is, I guess, good for us in a way. Flash prices have been going down. But if you look at just the components, no, they have not hit parity. However, the components, in the grand scheme of buying an enterprise system, the components only account for about 40% of the acquisition cost. The other 60% of the acquisition cost of the system comes in the form of software licenses, support contracts, and then lost capacity due to file system overhead or RAID or other data protection schemes that are specific to that system. And with the Nimbus design, that's where we've kind of overcome the competition. We have a much more efficient file system. We don't charge anything for the software, and our maintenance contracts cost less than half of what a typical disk array costs to maintain. So that we're so much less expensive there that despite the hardware being more expensive, net, at the end of the day, from a system acquisition cost perspective, we're about the same. And that is something that has been a hallmark of Nimbus, and we really haven't seen anyone else do. Most flash technologies cost significantly more. And with Nimbus, because we have that software technology that very few, if any, have, that's effectively allowed us to kind of subsidize bringing the total system acquisition cost down. Now, the waters are getting a little muddy here because some startups have gone out and started talking about cost per gig based on compression or deduplication and so on. And we find that that's a fairly unethical and not a real good way to go. That's not apples to apples with how people buy disks today. And furthermore, in your audience, the high-performance computing audience, most of those data sets don't dedupe or compress a lick. So you need to be able to tell the customer, hey, look, I'm shipping this many terabytes of flash versus this many terabytes for disk. Let's do an apples-to-apples comparison and see where things are. And Nimbus is the only one, again, I'm aware of that it costs parity when you look at it that way.
And then kind of a wrap-up question here, Tom. Do the flash, the component makers, Do they provide you guys with a pretty far-reaching roadmap that you can see where this technology is going and approximately what it's going to cost? And do they give you that kind of insight?
They do. With EMLC technology, the refreshes are not as frequent as they are with MLC because it's much more rigorous to qualify and ship a 30,000 erase cycle EMLC part than it is a 1,000 or 3,000 erase cycle MLC part. So whereas MLC is refreshing every 9 to 12 months or so with nanometer productions, EMLC is more like every 18 months. But this year, for certain, 2x nanometer EMLC technology will be available, and that alone will allow us to double density yet again, probably toward the end of this calendar year. After that, the next step is to go sub 20 nanometer. That'll take some time with the EMLC. It's probably another year and a half or 2 years before that's really ready. Well, definitely there is a lot of the duplication and racking and stacking going on. Unfortunately, storage benchmarks are very tough to interpret, even in a market, even where they're industry standards, like SPC benchmarks and so on. It's sometimes very difficult to see exactly what is being benchmarked. So for the sake of our benchmarks, we only talk about what one system in isolation is capable of. And we leave it at that. Yeah. And if someone wants to take 20 of them and put it in a rack and add up the number and say, hey, I got 20 million IOPS, they're more than welcome to say that. We're not going to, make things any cloudier than they already are. Or like that. So, we'll just say what our one unit is capable of, and look, we all know arithmetic, so we can do the math.
yeah, makes sense. Well, Tom Isakovich, I want to thank you once again for coming on the show today.
Well, it was my pleasure. Thank you very much for your insightful questions and for an opportunity to speak with your audience. So I appreciate it, and have a great day.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.